Number 11, this is that one that had the complex problem. You really don't need, I don't think you need part A for part B, but you definitely need this. So they're saying prove that omega, or W, is equal to, well, Z is x plus yi plus I, and down here is x plus yi plus 2. So write that down. And does that look anything like this? Not really. But we can make it a little closer, is I'm going to call this x plus y plus 1 times I, and this one is going to be x plus 2 plus yi. See how I grouped these two next to the I and this one for the real. Now you're ready to do the big move. Turn to your neighbor and tell them how we're going to remove this I from the denominator. Right, we're going to multiply this by the conjugate. Now the conjugate is not pretty in this case. It's x plus 2, what yi? Minus, yep. And so this is going to be x plus 2 minus yi. I'm going to put parentheses around here. And then this is going to be equal to, if you multiply this out, x times x plus 2 minus xyi plus y plus 1 times x plus 2 times I. And lastly, it's going to be negative y plus 1 times y I squared. All over. Oh, this is fun. X plus 2 times x plus 2. I'm going to have plus yi x plus 2 minus yi x plus 2. Do I have to write those? Are you going to spare me? Oh, thank you. These will cancel, right? But then the last part will be minus y squared I squared. Next, give myself some room here. Next thing we're going to do is multiply this out. So you're going to get x squared plus 2x minus xyi plus xyi plus xi plus 2I plus I, right? I think that's right. No. Y times 2, so it'll be plus 2IY. So we had yx2, yep, and then we had 1 times xi and 1 times 2I, right? Isn't it just 2I? Yeah. There's no y here, though. I think I got that one already, didn't I? 2yi plus 2I. And then you've got this at the end here, which is minus y squared I squared minus y I squared. All over x plus 2 squared minus, what's I squared the same as? Negative 1. So this is going to turn into plus y squared. Is that good? Is that good? That's good. Okay. Now let's see if we can take care of the top part. But look what happens to this minus xyi and the xyi. These two cancel. Let's put the rest together. So you get x squared plus 2x. What is yi squared? Yeah, it's plus y squared. Minus yi squared will be plus y. And then we're going to have plus x plus 2y plus 2 all times I. All over x plus 2 squared plus y squared. Did we get everything that they wanted us to have? X plus 2y plus 2, x squared plus 2x plus y squared plus y. Did it. Next, part C, it says, hence, your favorite word, show that when the real part of omega is equal to 1, you're going to end up with a straight line. Does this sound like terrible? It's freaky, isn't it? But this is going to be way easier than the last part. Because the real part, which is the real part of this, I'm going to highlight here, and I'm going to highlight here. Which is the real part, yellow or blue? Yellow. And what are they saying here? Set just the yellow equal to what? Do it. So what they're doing is they took the real part, which is in yellow, which is x squared plus 2x plus y squared plus y over x plus 2 squared plus y squared equals 1. So if we cross multiply, what you're going to get is x squared plus 2x plus y squared plus y equal to just x squared plus 4x plus 4 plus y squared. Anything cancel? Yep. What else? Oh, I love it. So all that's left is 2x plus y and 4x plus 4. And y is just going to be 4x minus 2x is 2x plus 4. There's the equation of a what? Straight line. And then they had the gall to ask for what else? The gradient. And what's the gradient? Isn't that awesome? That's great. All right, how are you doing? Is any questions on this? Kind of exhausting, isn't it? But is it doable? It's doable. It's doable. The part that you have to watch is your algebra. All right. So Marie's going to tell us how to do the last part. No, she's not. If you could look up here, that'd be great. So given the argument of z, by the way, this one I would never put on one of our tests. But it's kind of cool. So let me just show you how to do it. So theta is the same as the argument of anything, like z, or in this case, w. Okay? So what we're saying here is that theta is the inverse tangent of y over x. Remember that? They're saying theta is equal to what? Pi over 4. So do you get that? Is that part all right? Turn to your neighbor, tell them what you would do to solve for y over x. Stan, what do you think? What should I do to both sides? You said it. Take the tangent of both sides. Your honors pre-calc teacher did you well. Tangent of pi over 4. It was me. 1 is equal to y over x. And so if we cross multiply, y is equal to x. So what's neat about this is that if z is equal to x plus yi, right? And It said the real part was equal to 1. If the real part's equal to 1, then x is 1, and what will y have to be? 1. So let's find the magnitude of this. What's the modulus or the magnitude of it? Well, it's going to be the square root of 1 squared plus 1 squared, which is the square root of 2.